In the question, if you get convert the given decimal number to octal, then you have to divide it by 16. Whichever base they are given, on that base you have to convert. If I want to convert the number to binary, then you have to divide by 2. If I want to convert the same decimal number to octal, then the same number we have to divide it by 8. If I want to convert any decimal number to binary, then compulsory division process you have to follow. We want to convert this into binary, that's why divided by 2 you have to follow. Welcome back to one and all. Myself, Vasanta, lecturer in Computer Science, Vidhyaashram, Pre-University College, Temple of Excellence, Mysore. Today, we have to start with the second session of Data Representation chapter. Whereas already in this chapter, we have studied regarding introduction, regarding data representation, what do you mean by non-positional number system, then positional number system. Under positional number system, you have studied decimal number system, binary number system, octal number system, as well as hexadecimal number system in the previous session. Whereas on today's session, you will come to know how to convert a number system, especially decimal number to binary, decimal number to octal, decimal number to hexadecimal. Already I told you in the previous session, computer can able to understand only the binary languages, that is zeros and ones. Then how to convert a decimal number to binary as well as decimal number to octal as well as decimal number to hexadecimal number, regarding that today you will come to know. Whereas already I told you in the previous session, when you come on binary, it consists the digits 0 and 1 only. With that, in the base we used to write 2. If it is decimal number, then it contains the digits from 0 to 9. With that, in the base we have 10. If it is octal number, 0 to 7, and in the base we used to write 8 if it is octal number. Then if it is hexadecimal, 0 to 9 and A to F. And in the base we used to write 16. When they come on number system, especially positional number system, binary, decimal, octal as well as hexadecimal numbers. Whereas on today's class, you will come to know how to convert the decimal number to binary, decimal number to octal, decimal number to hexadecimal number. Regarding that, today you will come to know. Whereas, how to convert a decimal number already I told you, in the base we have 10. Number to any other base, where it may be binary format, or it may be octal format, or it may be hexadecimal format. If I want to perform that, then first step, divide the decimal number by the base value. In the question, if they given convert the decimal number to binary, then we have to divide that by 2. In the question, if you get a question like convert the given decimal number to octal, then you have to divide it by 8. In the question, if you get convert the given decimal number to octal, then you have to divide it by 16. Whichever base they are given, on that base you have to convert. First step, you have to divide the decimal number by the given base, whichever base value they are given. Then note down the remainder. Note down the remainder. First divide the number and note down the remainder every time. Then divide the resultant quotient by the same base. Whichever base value they are given, divide that once again by the given base value. Then once again note down the remainder, and you have to process this as long as the remainder, whatever remainder we are getting, you have to repeat the same steps again and again. Repeat the steps 3 and 4 until the quotient cannot be divided by any more than the result of the obtaining by writing all the remainder from bottom to top. Then we can get the resultant information. That will show you once by some problems. Consider here, convert the given decimal number. The decimal number, in this case, we are given 87. In the base, we have written 10. It means that it is a decimal number. Then, how to convert this into binary format? First step. So, 87 is the decimal number and the whatever the binary value that we know. Then, If I want to convert that into binary format, first step. See, 87 we have. See the first step. Here, divide the decimal number by the base value. Consider 87 we have, then divide it by 2. If it is binary, if I want to convert, then divide it by 2. If it is octal, then divide by 8. If it is hexadecimal, divided by 16. Now, 8 4s are, we have to convert there. 2 4s are 8, then 2 3s are 6, then remainder 1 you have to note down. Then in the same way, whatever result we have, see the steps here, note down the remainder and continue the process once again. Here, once again divided by 2 only. 2 2s are, then 2 1s are, remainder 1 you have to note down. Then in the same way, once again, here 2 10s are 20, remainder 1. See the steps? Then once again, 2 5s are, remainder here 0. 2 2s are 4, then remainder 1. Next, 2 1s are, remainder 0. As long as the quotient, if it is not possible to divide, till that we have to divide and you have to note down the remainder. If you observe this, here whatever result here we have, see, first you have to write down this value and then you have to move to upper direction. Then the result will be 1 0 1 0 111. See here in the example also we are written the same value 87 divided by 2, then 43 will get, note down the remainder 1. Then once again divide by 2, then 21, note down the remainder 1. Then divide it once again by 2, then 10s are 20, then note down the remainder 1. Then 2 5s are 10, note down the remainder, we are not going to get any remainder, that's why 0. Then 2 2s are 4, remainder 1. Then 2 1s are 1, remainder is 0. Then the result, here the last, here the number, this can be called as most significant bit and the here least significant bit. Note down the value from this. See, first 1, then 0, then next once again 1, next 0, then 1 1. Like this format, you have to write the value. Then here we are divided this by 2, then in the base we have written 2. It means that now we are converted the decimal number 87 to the equivalent binary number. Like this, you have to convert the given decimal number. See the steps? Divide the number by the base value. If I want to convert to binary, then divide by 2. If I want to convert that into octal, divide by 8. If I want to convert the same decimal number to hexadecimal, then divide it by 16. Then note down the remainder each and every time. Then once again the quotient, once again we have to divide until we are not going to be able to divide that number. See, this is the steps. Then consider few problems. Convert 27 to binary, octal as well as hexadecimal. Whereas in the exam, you will get the question, convert the given decimal number to binary for 2 marks. Or convert the given decimal number to octal. Or convert the given decimal number to hexadecimal. Like that, you will go to get the question. For 5 marks, in the same pattern, you are going to get. For example, convert the given decimal number to remaining all the bases. Now, see here, 27 is the decimal number. If I want to convert this into binary, then all the values you have to divide by 2 only. See, here 2 13s are 26, note down the remainder is 1. Then 2 6s are 12, note down the remainder 1. Then once again, 2 3s are 6. 2 3s are 6, we are not going to get any remainder, that's why note down 0. Then 2 1s are 2, then the remainder is 1 here. Now once again, here 2 1s are, here whatever result we are getting, that we will write here. Now write down the resultant from this to upper direction. Here 1 1 0 1 in the base 2. Now is it clear? In the same way, here once again 27, I want to convert this 27 to octal number. Then how to perform? See, if I want to convert this into octal number, then divide by 8 only. If I want to convert the given decimal number to binary, then divide by 2 only. Then in this case, what happens here? 8 3s are how much? Note down that and note down the remainder. Once again, 8 1s are 8 is not possible. Then the result will be 3 and 3 only. Then the result here 3 and 3 in the base we are written 8. Now is it clear? In the same way here also 27. 16 1s are 16. Then the remainder we are getting 11 here. Then 11 can be called as B here, then 1B is the resultant answer. As long as the variable is not possible to divide, till that you have to process here. Then consider one more problem, 138. It is a decimal number. How we identify? In the base we are written as 10. Then convert to binary, their equivalent octal as well as their equivalent hexadecimal number. Then how to convert? Once again the division process will take place. 138 we have to divide by 2 because we want to convert that into binary format. Then 2 69s we are getting 138, then the remainder is 0. Then once again divide this 69 by 2, then 34 is the remainder 1. Then once again divide this 34 by 2, then 17 is the remainder is 0. Then once again divide this 17 by 2, then 8 the remainder is 1. Then divide this 8 once again by 2, then here the quotient is 4, remainder is 0 here. Then once again divide that 2 2s are 4, then remainder is 0. Like this process will continue. Once again here I get the result 1 0. Is it possible to divide once again from 2 0? It is not possible. Then the result here, see 1 here we get, then 0, here 0, then here also 0, then here if you observe 1, then here 0, then here once again 1, and then once again 0 here. Now it means that you have to write from bottom to upward direction, and the result here we are written as base 2. It means that it is a binary number. From bottom to upward direction you have to write. The same number here we have, for example, 138. Now our agenda, we want to convert the given decimal number to octal number. Then once again division process. If I want to convert the number to binary, then we have to divide by 2. If I want to convert the same decimal number to octal, then the same number we have to divide it by 8. Then 8 17s are, then note down the remainder is 2. Then 8 2s are 16, but the remainder we get 1. Then how to write the result? Then see 2 I have written, then next 1, then once again 2. From bottom to upward direction we have to write, and in the base we are written as 8. It means that if I want to convert any decimal number to octal, then division process we have to follow, then divided by 8. Then once again consider the same number 138. I want to convert this into hexadecimal number. Then hexadecimal number means here 16 8s. From which number it will divide, find out that, and note down the remainder. 10 I am getting. But in the hexadecimal number, in the beginning class only I told you. Here it consists the digits from 0 to 9. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. After 9, on the place of 10, we have A, B, C, D, E, and then F. See, here on the place of 10, A represents 10, then 11, 12, 13, 14, and then here 15. Then if you get A, then what I have to write 10 means? A here. Then 8, A, 16. Don't write 10 here because it's a hexadecimal number. In hexadecimal number, it contains the digits from 0 to 9 only. Then on the place of 10, we have to write it as A here. That's why here the 10 can be written as A. 8, A in the base 16. In the exam, if you write 810 in the base 16, then it is totally wrong because 10 can be replaced by A here. Now is it clear? Next, consider one more problem. We have 422 is a decimal number. We want to convert this 422 to binary, octal as well as hexadecimal number. Then how to convert? Same pattern, 422 divided by 2s. Then 2 2s are 4. Then here 11s are, remainder is 0 here. Then once again we will divide that 211 by 2 once again. Then 105 remainder is 1. Once again we will divide this 105 by 2. Then 52 remainder is 1. Then divide once again 52 by 2. Then 26 remainder is 0. Then once again 26 we are divided by 2. Then 13 remainder is 0. Once again divide this 13 by 2. Then we are going to get 16 12, remainder is 1. Then divide this 6 by once again 2. Then 3 remainder is 0. Then once again divide this 3 by 2 2 ones are, then remainder is 1. Then write down the result. See, first start from here, 1, 1, then 0, 1, 0, 0, 1, 1, 0. See, 1, 1, 0, 1, 0, 0, 1, 1, 0. In the base, we have written as 2. Now is it clear? It means that if I want to convert any decimal number to binary, what is the procedure? Divide that by 2. If I want to convert any decimal number to octal number, then compulsory you have to divide that number by 8. Then see, 8 52s are, then remainder is 6. Because my agenda is to convert the given decimal number to octal number. Then divide by 8. 52s are, remainder is 6. Then divide this 52 by 8 once again. Then 6 are, remainder is 4. Then write down the value. Then the resultant will be 646 in the base 8. It is an octal number for the given 422 decimal number. This is the answer. Now in the question, if you get convert the given decimal number to hexadecimal number, then how to convert? Once again same pattern, divide that 422 by 16. Because now we want to convert this into hexadecimal number. Then 1626 is the remainder 6. Once again divide this 26 by 16, then 1 16, remainder will be 10. But it is hexadecimal number. Then what you have to write once again? Here once again I get 10. On the place of 10 I have to write it as A here. Then what is the result here? 1 on the place of 10 we are written as A. Then 6 in the base 16. Now is it clear? If I want to convert any decimal number, consider if I want to convert any decimal number to binary. If I want to convert any decimal number to binary, then compulsory division process you have to follow. We want to convert this into binary, that's why divided by 2 you have to follow. If you want to convert this decimal number to octal, then once again division process only, but divided by 8. In the same way, if you want to convert this decimal number to hexadecimal, then once again division process only you have to follow, but divided by 60. Now is it clear? That means on today's class we come to know how to convert a decimal number to binary, decimal number to octal, decimal number to hexadecimal number. Consider one more problem. Consider we have 281. It's a decimal number. You have to convert that into binary, octal as well as hexadecimal. Then what we have done? Once again 281 we have, that we will divide. 281, 2 1s are 2, then 81, 4s are 0, remainder 1. Note on the remainder. Once again divide this 140 by 2, then 70 is a, remainder is 0. Then divide this 70 once again by 2, then 35 is a, then remainder is 0. Then once again divide this 35 by 2, then 17 is a, remainder 1. Divide this 17 by 2 once again, we are getting 8, then remainder is 1, that is 6. 2 8s are 16, remainder is 1. Then once again divide this 8 by 2, then 2 2s are 4. Then here 4 2s are 8, then note on the remainder. Then here 2 2s are 2, 4, then here note on the remainder 0. Then 2 1s are 2, then here the resultant is 1, note on the remainder. Then write on the value from bottom to upward direction. Then 1 0 0 0, 3 zeros, then once again 1 1 0 0 1. This is the method to convert any decimal number to binary format. Same way, we have one more formula under that 281. That's a decimal number. We want to convert this into octal number. Then once again divide that 281 by 8. Then 35 is a, note on the remainder is 1. Then divide this 35 by 8. Then 4 is a, remainder is 3. Then the result you have to write 431. Then what is the value? For 281 decimal number, the resultant will be 431 is the octal number. Now is it clear? Now in the same way, the same number we have considered. For example, 281, here 16s we have to divide. Then 16, 17s, note down the remainder 9. Then divide the 17 by once again 16. Then 1's remainder is 1. Then here we have 9. Directly we can able to write because in hexadecimal number 9 is also considered 0 to 9 and then A to F. Then the result will be 119 in the base 16. In your mind, you have to keep that. On today's class, you have converted 3 methods. You have learned 3 methods. One is decimal to binary. Under that, in the decimal number, there we have the base 10. In binary, we have base 2. In this method, what we have to do? We have to go with division process only, but divided by 2, compulsory. In the base, whatever result we want to generate, to that base, we have to divide it by 2. If I want to convert decimal number to octal, then in the base we have 8. That's why division process only, divided by 8 only. If I want to convert decimal number to hexadecimal, in the hexadecimal number, the base we have 16. Then here also, if I want to convert any decimal number to hexadecimal number, once again division process only, but divided by 16. Then on today's class, you have learned 3 methods: decimal to binary, decimal to octal, decimal to hexadecimal. Here, one thing you observe, here we are not using the fractional part, only the integer part. For integer part, how to perform regarding that on today's class you come to know, is it no? Whereas if you have fractional part, then we have to follow different method. For example, consider here we have 281.06. It's a decimal number. Then how to convert binary? Then this part as usual, now how we are written, the same method will perform. But for fractional part, we have to follow multiplication process. That we will explain in the next class. In the next class, you will come to know how to convert a decimal number fractions. Decimal number fractions to binary. Decimal number fractions to octal. Decimal number fraction to hexadecimal. How to convert? Then what do you mean by ones complement? How to find ones complement, as well as how to find twos complement, how to convert the given binary to ones complement, twos complement, and how to convert a binary to decimal, binary to octal, binary to hexadecimal. Whereas on today's class you have studied decimal to binary, decimal to octal, decimal to hexadecimal. Whereas in the next class you will come to know the reverse of that. That is binary to octal, hexadecimal, and the same way hexadecimal to the remaining base. That we will explain in the next class. Thank you for all of you.